Hi students, problem number 3. A beam of light consisting of red, green and blue is incident on a right-angled prism as shown in the figure. So these three colors, red, green and blue, are separately incident, not together. First, red is incident at an angle of 45 degree. Next, green light is incident on a right-angled prism at 45 degree. Similarly, third one is a blue light is incident on the right-angled prism at 45 degrees separately. The refractive index of the material of the prism for red, green and blue colors are 1.39, 1.44 and 1.47 respectively. So the refractive index of glass is not constant for all wavelengths. It is different for different colors and wavelengths, because you have studied when white light travels inside glass means all the different colors travel with different speeds. So the red travels faster and violet travels with the least speed inside glass. That is why the refractive index of glass for red, green and blue are different. Their values are given respectively. For red 1.39, for green 1.44 and for blue it is 1.47 respectively. Which of these colors will suffer total internal reflection? So what is common for all these three colors is the angle of incidence. So I will write angle of incidence I is equal to 45 degree. Okay. Then the refractive index of glass for red color it is 1.39, and for green color it is 1.44, and for blue color it is 1.47. These are the quantities which are given in the problem. Okay. So which of these three colors will suffer total internal reflection, we have to find out. Now under what condition the total internal reflection will take place? First condition is what? Light should travel from the denser medium to the rarer medium. So while coming out of glass into air, which of these colors will suffer total internal reflection, we have to find out. What is the second condition is? Angle of incidence inside the denser medium must be greater than the critical angle. Okay. So the condition for total internal reflection is angle of incidence must be greater than the critical angle. Therefore, taking sine value on both sides, sine of the angle of incidence must be greater than the sine value of the critical angle. Is it not? Now what is the angle of incidence given here is 45. So sine 45 degree, okay, sine 45 degree must be greater than sine of I critical. Okay. Now sine 45, what is the value of sine 45? Sine 45 degree is equal to 1 by root 2. Okay. What is the relationship between critical angle and the refractive index? Relationship between the critical angle and the refractive index is sine of critical angle is equal to 1 by n. Is it not? We have derived this condition in total internal reflection. So on the left hand side, in place of sine 45, what shall I substitute is 1 by root 2. And on the right hand side, by formula, sine of IC is equal to 1 by n. Okay. So I will write left side is 1 by root 2 must be greater than 1 by n. Understand? Okay. Now I will cross multiply so that n into 1. Left side is what? N. So we can also rewrite the same. N should be greater than root 2, or the refractive index of the material n should be greater than square root of 2 is 1.414. So this is the condition, understand, under which total internal reflection will be satisfied. Okay. Now you see here for red color, what is the value of refractive index? 1.39. is 1.39 greater than 1.414? No. So the red color will not satisfy this condition, therefore it will not undergo total internal reflection. Is it not? Then you see here, for green color it is 1.44. 1.44 is greater than what? 1.414. Therefore green color will suffer total internal reflection. And for blue it is there is refractive index is 1.47, which is greater than this 1.414. So here M green, okay, that is greater than 1.414, and M blue is also greater than 1.414. Therefore green and blue, okay, green and blue light, okay, light rays will undergo total internal reflection. So they will undergo total internal reflection. So in the picture also it is shown here I is equal to R for green color, and for blue also I is equal to R, because they are undergoing total internal reflection. Understand, students? I hope you must have understood well. Fine.